The two-lane road that leads from Interstate 75 to the main gate at Georgetown, Kentucky, does not look like the approach to one of the most productive industrial facilities on the planet. There are horse fences along the verge, a few signs for bourbon distilleries, the green and gentle topography of the bluegrass region rolling away on either side. Then the trees thin out, and the scale of the place reveals itself in stages. First the parking lots, holding several thousand cars belonging to the people who work inside. Then the perimeter of the buildings themselves, low and pale and stretching toward the horizon in a way that resists the eye's attempt to measure them. Then, almost as an afterthought, the rail spurs and the truck staging yards and the test track curving away behind the main complex. The facility covers more than 1,300 acres, encloses something on the order of 9 million square feet under roof, and on this particular spring morning in 2026, it is preparing to mark its 40th anniversary of operations. The governor of Kentucky has been by recently. The cumulative production counter inside the visitor center has long since passed 14 million vehicles. This is Toyota Motor Manufacturing Kentucky, known internally as TMMK, and by the company's own designation, it is the largest Toyota vehicle manufacturing plant anywhere in the world. The headline that has circulated about this place, the claim that a finished car rolls off the line every 60 seconds, is essentially accurate, though the accuracy depends on how you choose to count. The plant has the capacity to produce roughly 550,000 vehicles and more than 700,000 engines per year, drawing on a supply network that includes over 400 suppliers across the United States and more than 100 within Kentucky alone. Translated into the rhythm of a working shift, those numbers do indeed work out to a vehicle completion roughly once a minute on each of the plant's main assembly lines. Whether that constitutes building a car in 60 seconds is a question worth holding in mind, because the answer reveals more about modern manufacturing than the headline itself. A car is not built in 60 seconds. A car is finished every 60 seconds. The distinction is not pedantic. It is the difference between understanding what a factory is and being impressed by a number. A single Camry on the TMMK floor has, by the time it rolls onto an inspection bay at the end of the trim line, already spent something on the order of 18 to 20 hours moving through the various stages of the plant. It has been stamped from sheet steel, welded into a body, primed and painted, fitted with thousands of components, filled with fluids, programmed with software, and tested in motion before a human driver hands it off to the inspection team. What the 60-second figure describes is not the duration of the car's production, but the pulse of the line, the takt time, the rate at which the parallel processes of the plant have been synchronized so that one finished vehicle emerges per minute, even though hundreds of cars are simultaneously in motion at every stage upstream. To see what this actually means, it helps to walk the plant in reverse, starting at the end where the finished cars come off. The trim line is the most visible portion to visitors, the section where the painted body, having traveled in from the paint shop on an overhead conveyor, descends to floor level and begins receiving its interior components, the dashboard, the seats, the wiring harness, the headliner, the instrument cluster. Each station along this line has a target cycle time matched to the overall plant takt, and a worker or a small team of workers performs a defined sequence of tasks within that window before the car moves to the next station. The choreography is precise enough that the workers do not need to walk more than a few steps from their tool boards. The parts arrive at their stations in the exact order that the cars themselves are arriving, sequenced by an internal logistics system that knows which Camry is white with a beige interior bound for a dealer in Atlanta and which one is a hybrid trim with the upgraded sound package destined for Cincinnati. Upstream of the trim line sits the paint shop, which from a visitor's perspective is the most alien stage of the process. The painted body emerges as a familiar shape, but inside the paint enclosure, the work happens in a controlled environment that resembles a clean room more than a traditional factory floor. The body is dipped in successive baths to clean and treat the steel, then coated with an electrostatic primer that adheres to the metal under voltage, then sprayed with base coat and clear coat by robotic arms that can adjust their patterns to the specific geometry of each panel. The whole sequence runs at temperatures and humidities carefully controlled, because paint chemistry is unforgiving. A defect in the paint shop, an inclusion, a sag, a fisheye where a contaminant has disturbed the surface, will almost certainly require the body to be diverted, sanded, and resprayed, and the cost of that diversion is large enough that the plant maintains rigorous filtration on every cubic meter of air entering the space. Behind the paint shop is the body shop, and the body shop is where the popular image of robotic manufacturing comes closest to the reality. Several hundred industrial robots arranged in cells along the line perform thousands of spot welds on each body shell, joining the stamped panels into a unitized structure. The trajectories of the welding arms have been programmed and refined over decades, and the geometry of the resulting body is held to tolerances measured in fractions of a millimeter, because a misalignment of even half a millimeter at this stage will become a buzz or a wind noise or a misfit panel by the time the car reaches the customer. The body shop is also where the marriage between automation and human attention has been negotiated most carefully. Toyota has, at various points over the past 2 decades, deliberately reduced automation at certain stations and returned the work to human operators, on the principle that a human can notice when something is subtly wrong while a robot will continue to execute its program until told otherwise. The body shop today contains both, with humans performing inspections, quality checks, and the kinds of judgment-intensive tasks that machines still struggle to replicate. Further upstream, the stamping shop produces the panels themselves, feeding coiled sheet steel into presses that exert thousands of tons of force. Each stroke of a large press shapes a door or a hood or a fender in a fraction of a second, and the panels are stacked, inspected, and delivered to the body shop on a sequence that again matches the rhythm of the line. And before the stamping shop, in a different building, the powertrain plant produces these engines and transmissions that will eventually be installed on the trim line. TMMK is somewhat unusual among Toyota's North American facilities in that it builds engines on site at very large scale, with engine production capacity actually exceeding vehicle production capacity, allowing surplus engines to be shipped to other plants in the network. The system that holds all of this together is the production philosophy that Toyota developed over the decades following the Second World War, built around principles that the company itself summarizes with terms like just-in-time, jidoka, and Kaizen. These terms have been repeated so often in business writing that they have begun to feel like marketing slogans, but inside the plant, they refer to specific operational practices that have measurable effects on cost, quality, and time. Just-in-time means that components arrive at the assembly station at the moment they are needed, in the sequence they are needed, rather than being stockpiled in warehouses and then sorted later. Jidoka, often translated as automation with a human touch, means that machines and workers are equipped to detect abnormalities and stop the process when something is wrong, rather than continuing to produce defective output. Kaizen, the most culturally laden of the three, means that every process, every workstation, every task is treated as something that can and should be improved continuously, through small refinements suggested by the people who actually do the work. The most visible artifact of this philosophy on the floor is something called the Anden cord, a physical pull cord or button at each station that any worker can activate to slow or stop the line. The willingness to pull that cord and the cultural expectation that workers will pull it when they see a defect rather than letting it propagate downstream is not a marginal detail. It is one of the load-bearing elements of the system. A plant that produces a finished car every 60 seconds has very little tolerance for accumulated defects, because a single problem unnoticed at an early station can compound into a much larger problem by the time the vehicle reaches inspection. The economic logic favors stopping the line for 2 minutes now over disassembling a finished car for 2 hours later. What does not appear in the popular accounts of TMMK and what is worth dwelling on is the human cost of operating at this rhythm. The plant employs roughly 9,000 people, the majority of whom work directly on the production lines, and the work itself is physically demanding in ways that are not always visible from a distance. Repetitive motions performed several hundred times per shift on a cycle that cannot be slowed for individual fatigue, place real strain on shoulders, wrists, backs, and knees. Toyota has invested heavily over the years in ergonomic redesign, in rotation schemes that move workers across different tasks, in fitness programs and physical therapy, and the company's safety statistics have improved meaningfully over the decades. But the fundamental tension between the rhythm of the line and the bodies of the people running it does not disappear. And the plant's labor history, including the various conversations about unionization that have surfaced over the years, reflects that tension. The plant also exists within a broader economic ecosystem that is easy to underestimate. Those 400 suppliers feeding components into TMMK employ tens of thousands of additional workers across the eastern United States, many of them in small towns that have built their economies around a single contract with the Georgetown plant. The truck drivers who haul finished vehicles to dealers, the rail workers who load the trains heading west and south, the engineers who design the tooling, the software developers who maintain production control systems, all of them are part of what TMMK actually is. The plant is sometimes described as the largest single-site private employer in Kentucky, which is true. But the more meaningful number is the indirect employment that radiates outward from it across the supply chain. A plant of this scale is not just a building, it is a node in a network, and the network is what makes the building possible. In March of 2026, Toyota announced an additional $800 million of investment in the Georgetown facility, on top of the substantial sums it had already committed in previous years, with the specific goal of preparing the plant to produce a second battery electric vehicle model. The investment is part of a broader $1 billion commitment across Toyota's Kentucky and Indiana operations, and it represents a meaningful shift in the company's manufacturing posture in North America. For most of TMMK's 40-year history, the plant has built gasoline-powered Camrys and gasoline-powered Avalons and the Lexus ES sedan. In more recent years, it has added hybrid variants. The transition to building battery electric vehicles at the same site, on lines that will eventually need to accommodate both internal combustion and electric powertrains, is a substantial engineering undertaking, and the $800 million figure reflects the scale of the retooling required. This brings us to the part of the public conversation about Toyota's future that has generated the most speculation, which is the company's program for so-called solid-state batteries. The technology has been promised for years, often with timelines that have slipped repeatedly, and it deserves a careful description rather than a hyped one. A solid-state battery replaces the liquid electrolyte found in conventional lithium-ion cells with a solid material, which in principle allows for higher energy density, faster charging, longer life, and improved safety. The principle has been understood for decades. The practical difficulty has been finding solid electrolytes that can match the conductivity of liquid ones at room temperature, manufacturing those electrolytes at scale, and integrating them into cells that can be produced reliably and cheaply. Toyota has received approval from Japan's Ministry of Economy, Trade and Industry to begin solid-state battery production, with initial output beginning in 2026 and a planned ramp toward volume manufacturing around 2030. In January of 2026, one of Toyota's partner companies broke ground on a dedicated solid-state electrolyte facility expected to come online by the end of 2027. The company's own published roadmap targets the launch of vehicles equipped with first-generation solid-state batteries in the 2027 to 2028 window, with claimed ranges potentially reaching towards 600 miles on a single charge. These are real plans backed by real capital, and they distinguish Toyota's program from the more speculative claims made by some smaller battery startups. They are also, it should be said, honestly plans rather than achievements. The history of battery technology is full of breakthroughs that performed beautifully in the laboratory and then encountered unexpected difficulties at production scale. Whether Toyota's solid-state batteries will deliver on the promises being made for them, and on what timeline, will not be known until cars equipped with them have spent several years in the hands of ordinary customers in ordinary climates. What can be said with more confidence is that the plant at Georgetown, like the rest of Toyota's manufacturing network, is being asked to adapt to a kind of change that it was not originally designed. For the lean production system was developed to optimize the manufacturing of mechanically similar vehicles with incremental variations. Asking that same system to absorb a transition to fundamentally different powertrains, different body architectures, different software stacks, and different supply chains is a genuine test of the system's flexibility. So far, the evidence suggests that the system is adapting slowly with the same incremental discipline that built it in the first place. The plant has not been torn down. The line has not been replaced overnight. The transition is happening in stages through retooling and reskilling and the gradual introduction of new product lines alongside existing ones. There is something instructive in that pace. The story that captures attention online, the story of a factory that builds a car every 60 seconds, tends to encourage a particular kind of admiration, the admiration of speed, of throughput, of records. But the more interesting story, the one that emerges from a careful look at how TMMK has actually evolved over 40 years, is a story of patience. The plant did not become what it is through a single transformative investment. It became what it is through 4 decades of small refinements, each one incrementally cheaper, faster, or better than what came before. The same patience is what will determine whether the plant successfully navigates the next decade of transition. The headlines about solid-state batteries and electric vehicle launches will come and go. The actual work, the long, careful work of building good cars consistently, will continue in roughly the same rhythm it always has. As the morning shift gives way to the afternoon, the plant does not slow. The line continues. Finished cars accumulate in the staging yard, are inspected one final time, are driven onto transport trucks bound for dealers across the country, are replaced on the conveyor by the next car coming. Down behind them, inside on the assembly floor, a worker hears a soft chime and looks up to see that the andon system has registered a brief stoppage at a station several positions ahead. Within 90 seconds, the issue has been resolved and the cord is released and the line resumes. No one comments on it. It is exactly the kind of thing the system was designed to absorb. The rhythm holds. And somewhere in that holding, in the unspectacular discipline of a place that has done the same difficult work very well for 40 years, is the real answer to the question the headline only pretends to ask. If the workings of a place like this interest you, the patient kind of curiosity that goes beyond the headline number, there is a great deal more to explore in the broader story of how modern manufacturing actually functions, how supply chains hold together or fail, and how the transition to electrified transportation is reshaping plants like Georgetown around the world. Those stories tend not to fit into a single video, but they are worth following over time.